Hi boys and girls. Today we are going to learn about triangles and four-sided figures. Before we move on to that, we have to review all of the geometry terms that we know because we're going to actually use all of that to find unknown angles. So let's review. First, if I have a straight line and I have adjacent angles on that line, I know that angle A plus angle B plus angle C will equal 180 degrees if they all meet at one point. Okay? Next, let's look at these two lines. Angles opposite each other at the intersection of two lines are equal. Vertical opposite angles, angle A and angle B, are equal. Angle C and angle D equal. All right, what else have we already learned? Let's look up here. We know that the sum of angles around a point, so I have angle A, angle B, and angle C, they all meet at one point. I know that all those angles, when added together, equal 360 because they make a complete circle. Angle A plus angle B plus angle C equals 360. Next, we have a triangle. So I know definition of a triangle, the sum of the three angles is going to equal 180 degrees. So if I add angle A, angle B, and angle C together in a triangle, I am always must get 180 degrees. And also we have here a triangle. We have a right triangle. We know when we see that square that it's 90 degrees. So if this square is 90 degrees, I automatically know that the other two angles, angle A and angle B, must also add up. Their sum must be 90 degrees because 90 and 90 is 180. And a triangle always has to have 180 degrees. So that's a right angle. So the two other angles must be 90 degrees. All right, we're going to continue on. All right, let's continue. Here I have a triangle with a straight line coming off of this. This is an exterior angle of a triangle is equal to the interior opposite angles. That means that this angle that's created from coming off of the triangle will equal the sum of these two interior opposite angles. Not the angle here next to it, but the two opposite angles of the exterior angle will be equal in their sum to that angle. So angle C is equal to angle A plus angle B. Isosceles triangle, that means two sides are equal. We are showing that by these little lines here. If two sides of a triangle are equal and the third side is not equal, it's called an isosceles triangle, and the opposite angles are equal. So if this side and this side are equal, that means that the opposite angles, so this opposite and this opposite angle, are equal. So angle A and angle B are equal because this is an isosceles triangle. The opposite angles of the equal sides are also equal. Lots of equal. Okay, we have over here an equilateral triangle. So an equilateral triangle means all the sides are the same. You can see that I have little lines on all of the sides. When all of the sides are the same, all of the angles are also the same, and they have to each be 60 because 180 degrees, which is the sum of all the angles of a triangle, divided by 3 is 60. So 60 is going to be the measurement of every angle inside that triangle. Let's keep going. Here we have a parallelogram. Parallelogram is a four-sided figure with two pairs of parallel lines equal in length. So you can see I have shown parallel by putting arrows on the lines that are parallel here and two arrows on the parallel lines here. I have also, as you will see, marked the sides that are equal with short cross lines. I have these cross lines here, and then I have two cross lines to show that these two are the same length, those two are the same length. In a parallelogram, the opposite angles are equal. So that means angle A and angle C are equal. It means angle D and angle B are equal. Opposite angles of a parallelogram are equal. A parallelogram also has the sum of each pair of angles between the parallel lines is 180. So if these lines are parallel, that means that these two angles and these two angles are equal to each other. So angle A and B equal 180, angle C and D equal 180. Then I can look at these two parallel lines and say that B and C are equal to 180 and angle A and D are equal to 180. A lot to take in. Remember, this is just a review. You've had all this before, but we just have to review it so we'll get ready for our triangles. All right, over here I have a rectangle. A rectangle is a parallelogram, but all the angles are 90 degrees. I think you already knew that. Here we have a rhombus. A rhombus is an equilateral parallelogram, meaning all the sides are the same length. It can be divided into two isosceles triangles. So I've divided it, and this is an isosceles triangle. These two sides are equal. These two sides are equal, which means that these two angles are equal, and so are these two angles, angle A and B, and if this was C and D. Okay, we're almost done with the review. All right, here we go. This is a square. A square is a rhombus. Remember, a rhombus is an equilateral parallelogram with four equal sides. Well, it has four equal sides, which makes it a rhombus, but because it has 90-degree angles, it is also not just a rhombus, but a square. And then finally, we have what's called a trapezoid. Trapezoid sounds like anyway, I won't tell you, like I'm thinking music video, trapezoid. The trapezoid is a four-sided figure with only one pair of parallel lines. These are the parallel lines. Parallel lines just mean two lines that go on forever and never touch, and they are the same distance apart. These parallel lines will not be equal in length. Let me say that again. In a trapezoid, the parallel lines will not be equal in length, because if they were, it wouldn't be a trapezoid. Now, in a trapezoid, just like in a parallelogram, the angles that are between the parallel lines make 180 degrees. So the sum of each pair of angles between two parallel lines is 180. Angle A and angle B will be 180. Angle C and angle D will equal 180. And you're saying, what's this L you keep putting up? That's supposed to be the symbol for angle. It should look more like that, but I do a little, I make it a little bit my own. But that just means angle. When you see that, that's what that means. All right, so we're going to, now that we have done our review, we've reviewed all the shapes that we know so far, and their different angles, now we can get on to learning what we were supposed to learn, which is triangles. Okay, here we have figure ABCE. We know that it's a parallelogram. CDE, okay, is an equilateral triangle. I'm going to put okay, so now I have marked it as being a parallelogram, and I have marked this as being an equilateral triangle. And I know that BCD is a straight line. So if CDE is an equilateral triangle, what can we say about its angles? Equilateral triangle, if all the sides are equal, all the angles have to be equal, they all have to be 60 degrees. So I know that all of these angles are 60. Okay? Now, ABCE is a parallelogram. What can you say about its angles? I can say that these angles are going to equal 180. These angles are going to equal 180. These angles are going to equal 180. what I can also say is, because this is a straight line, if this, and this is the point where these two angles connect, that 60, angle P and angle Q, have to equal 180. So I can say 180 minus 60 will give me 120. So now angle Q is 120. Because this is a parallelogram, if Q is 120, R, which is the opposite, must also be 120. I also know, because ABC is a parallelogram, that if angle Q is 120, angle Q and angle S have to together equal 180. So 180 minus 120 is 60. So angle S is 60 degrees. And because it's a parallelogram, if angle S is 60, the opposite angle over here, E, is also 60 degrees. I can also say that ABDE is a trapezoid. So I can say that this side of the trapezoid equals 180, which we've proven. Let's see if this angle and this angle equal 180. 60 and 60 is 120. 120 plus 60 is 180. So I can find all of that out by having just known that this was an equilateral triangle. I could find all the other angles of that unknown, well, not the shape of the shape, but all the unknown angles. That is what you're learning to do. From everything that we've learned, I have given you notes on everything, the geometric review that I did. You have all those notes, so you are certainly prepared to do this. It's like a puzzle you're figuring out. That's what I like about geometry, because you can see it and because you can figure it out. Figure out the answers, figure out the puzzle. So let's look at this, this figure. So you are given that XYZ is a straight line. XYZ, so this is a straight line. I am also given that XW, this line, and XY, this line, are equal. So I have my little crossbars there to say they're equal. I also know that WXY, angle WXY, is 38 degrees, so I put that there. They want me to find out what angle WYZ. WYZ. Oh, WYZ. They want me to find this angle. Okay? They want me to find that angle. All right. That's not that hard. And you're like, yes, it is. No. Okay, first thing I know is that this is an isosceles triangle. So I know from looking at my notes or from remembering what we just discussed earlier that the opposite angles, W and Y, have to be the same, okay? And I also know that all three angles of a triangle have to equal 180 degrees. So if I subtract the only angle that I have, which is 38, so if I subtract 38 from 180, I get 142. So these two, the sum of these two is going to be 142, but I'm going to divide by 2 because I know these have to be equal. So 2 into 142, 2 into 14 goes 7 times, 2 into 2 goes 1. So here I have both of those angles equal 71 degrees. Now that I have the angles of my triangle, I can find this missing angle. If XYZ is a straight line, and I know it is, and this is extending from this triangle, I can subtract 71 from 180, and I can get this missing angle. Because this is a straight line, these two angles together have to equal 180. So when I do that, I get 109. Now, I could also have found that one other way. Remember the rule that says that a line that extends from a triangle, this angle has to equal the opposite interior angles. So it has to equal this angle and this angle added up. So let's see if 71 plus 38 also equal 109. 8 plus 1 is 9, 7 plus 3 is 10. Ta-da! So there were two ways to find that angle. I could use opposite interior, or I could use the definition of a straight line. Okay, we're moving on. We're not going to do too much more. This is trapezoid ABCD. It's kind of upside down from what we were looking at earlier, but as you can see, we have a four-sided figure where we have one set of parallel lines and the lines are not the same length. So that's a trapezoid. We know that line AD and BC are parallel. We write parallel like two slanted lines together. On the figure, we have them with our arrows. We also know that angle ABC is 82 degrees. We know that angle ADC is 48 degrees. So we have to find angle BAD, BAD, and angle BCD. Now, because it's a trapezoid, we know each pair of angles between parallel lines have to equal 180 degrees. So all I have to do then, these two angles have to equal 180. These two angles have to equal 180. So 180 minus 82 gives me 98 degrees here. And then 180 minus 48. That gives me 132. So BAD, that angle's 98, and BCD is 132. Don't forget your little degree sign when you're writing in degrees. Okay, we're going to do one more, and then you guys will be ready to go on your own. All right, here we have rhombus, WXYZ. We know that a rhombus has 4 equal sides. So we know that all the sides here are the same. If all the sides here are the same, we know that this triangle and this triangle are isosceles triangles. So we know that this angle and this angle have to be the same. We know that this angle and this angle have to be the same. Because it's a rhombus and a rhombus has parallel lines, we also know right off the bat that angle WZY equals 84 degrees. Now, in order to find this, we have to, once again, say there are 180 degrees in a triangle. We must subtract the angle that we have. We get 96. So that means this angle and this angle together equal 96. We're never going to divide. 2 into 9 goes 4. Subtract, bring down. We get 48. So that means this angle, this angle, and this angle are all equal to 48 degrees. This is not as hard as it seems. Once you have learned the rules of geometry and the different figures, you can figure out just about any angle. To check this, we would add 84, 48, and 48. And of course, we're trying to get what? 180. 8 and 8 is 16, plus 4 is 20. 8 and 2 is 10, 14, 15, 16, 17, 18. Check. So you are ready to do workbook exercise 24 on your own. Use your notes so that you have everything that you need to figure out the missing unknown angles. Good luck.